Hello, welcome to your video on quadratic graphs. This is part 2 of the first lesson. You will be able to graph the parent function y equals ax squared and then also y equals ax squared plus c. First thing we need to talk about are the vocabulary words domain and range. Domain are all the x values possible on the graph. In other words, how far left and right can the graph go? And the range is all the y values possible from the graph. So if the graph were to continue on forever, what would all of the possibilities be going up and down on that graph? First question is, how do I graph y equals ax squared? The equation I'm going to use is y equals 1/3 x squared. So what you're going to do first is just make a table of values. So for this one, I have x. You want to pick some positives, some negatives. It doesn't really matter. Anything is fine. I'm going to pick 0, 3, and 6. And you'll see why I didn't pick any negatives here in just a second. So 1/3. And then I'm dragging and dropping that 0 in for x squared. Order of operations, I have to square first. So 0 squared is 0, and then 0 times 1/3 obviously is 0. So then the coordinate point for that, I'm just going to make this smaller temporarily, would be then 0, 0. For 3, I have 1/3 times 3 squared. So 3 squared comes first, and then times it by 1/3, I get 3. And so then my coordinate is going to be 3, 3. And then 1/3, and then times 6 squared. So 36 times 1/3 will be 12. So the coordinate there then is going to be 6, 12. So I can take that information and use it to plot my points. So here we go. I have 0, 0 as my first one. And then my next point is 3, 3. And then I have 6, 12, and I'm running out of space here. 8, 9, 10, 11, 12. It would be up here. Now you can obviously make your graph fit this. I just used a generic. But the reason why I didn't put anything negative is because the nice thing we know about parabolas is that it reflects across the axis on your vertex, and the vertex is 0, 0. So I can just reflect it across the y-axis, which is x equals 0. That's going back in the day from a while ago. That y-axis is x equals 0. So then I can reflect it over that line, and I will have this point here, and then this point up here, and then I can just connect this. And there's my parabola. The domain then, think about the domain is going x and y going across left to right. And if this were to continue, it would actually be all numbers. All real numbers are possible there. And then the range is up and down, how far I can go up and down. I can go up forever. It's down that I can't, because the lowest it goes is that x-axis at 0. So my range then is going to be y can be greater than or equal to 0. How do I graph y equals ax squared plus c? This is just a teeny tiny bit different, and you can see that because there's this plus 3 on the end. And so I'm going to walk you through how to do these ones. They're pretty much the same. They're just tweaked just a tiny bit. And to do that, I'm going to compare this right here. So let's go with numbers 0, 1, and 2. Just to make it easy, again, we know we can reflect the points across. So I could have negative. We'll just do one negative here. So here, if I were to use the parent function here, ax squared, which is what we just learned about, it would be 2 times 0 squared, which would obviously be 0. This one would be 2 times 1 squared, which would be 2. This one would be 2 times 2 squared. Order of operations, keep in mind, and that will give you 8. And then if I had 2 times negative 1 squared. Negative 1 squared is 1, so then this would give you an answer of just 2. So now what happens? We want to compare what's going to happen when I have this plus 3 on the end. If I know it was 0, and then I add 3, it's going to then become just 3. When I had 2, because that was the 2x squared, I add 3, it now becomes 5. Same thing with these ones. And now I can plot those points. So my coordinate would be 0, 3, 1, 5, 2, 11, and then negative 1, 5 would be my points. And then I'm also going to, we'll plot these first. So 0, 3, 1, 5, 2, 11, and I'm kind of running out of space, but we'll make it up here. And then negative 1, 5, reflecting, remember? And this one's going to be here. So here's my graph for y equals 2x squared plus 3. I'm going to graph this y equals 2x squared just so you can see what happens. So that would be 0, 0, 1, 2, 2, 8, negative 1, 2. And right away, you can see what happened here. And you're probably noticing that what happened is it stayed the same shape, but it moved up 3 spaces, but the size didn't change of it. It's not any wider or any skinnier. It's exactly the same. And so that's your takeaway, is when you have something that's being added or subtracted, it's just going to shift it up or down. The A term is what's going to make it wider or skinnier. That C term is going to tell you if it's moving up or down. So it is your turn. There is a Google form to go with this, and that's found on my website. You are going to first graph y equals negative 3x squared, and then you're going to tell me the domain and the range. Remember, domain is going across the x-axis, y is going up and down. And then number 2, you're going to graph y equals x squared minus 3, and then find the domain and range. On your Google form, you're just going to tell me the domains and ranges of these 2 problems. We will talk about what your graphs should look like in class. That is the end of your video. Thank you for watching. Have a fabulous day.